Occasionally in algebra, we encounter equations that might look like perfectly normal equations, but in fact, they have no solution. Consider this equation, which just magically appeared. First of all, you'll notice that it has variable on each side of the equation. 5x over here, 2x, and a 3x term over here. You'll probably notice that the right-hand side of the equation quickly simplifies to 5x plus 7. So the 2x, the 3x give us 5x. At this point, it should already look a little weird. We have, on one hand, 5 times some number plus 3, and on the other hand, we have 5 times some number plus 7, but we're saying they're equal. According to the laws of algebra, I should be able to subtract 5x from both sides of this equation. When I perform this perfectly logical step, I get something even stranger. Those cancel, leaving us with 3, and on the right-hand side, these cancel, leaving us with 7. Now we arrive at something that really just won't do. I, for one, don't want to live in a universe where 3 equals 7. But we followed all logical steps, so the only conclusion that we can come to is that our original equation, the one we started with up here, this original equation could not have been well formed, or in other words, it had, you guessed it, no solution. So that's one example of how an equation could have no solution. I wonder what other type of examples that you could think of. The key thing, though, is to notice that you start with an equation, and by following logical steps, you argue it down to something which clearly cannot be.